Hi everyone, I am Bihan Chakraborty and today I'll be discussing LeetCode's 525 problem, that is contiguous array. So this is February 2022's day 4 problem. I have already created videos on the past 3 problems. If you haven't checked it out, you can definitely, in case you are stuck. So now moving back to the problem, we have been given a binary array norms. So what is a binary array? Binary array is basically an array that consists of only zeros and ones. Okay, so we have been given such an array and we have to find the maximum length of the subarray that contains equal number of zeros and ones. So we need to find such a subarray that has equal number of zeros and ones, and we need to maximize the length of that subarray. So in the first condition, in the first array we have 0 1. So for the whole size of the array, this is my subarray and it has 1 0 and 1 1. So I can say that this is a valid subarray and it has size 2. So this is my answer. For this case, I have 0 1 here and 1 0 here. So that is the maximum length I can gain here. So answer is 2. So let me go to my drawing pad. Yeah. So here, for this test case, what are the possible values? For size 2, these are valid. Okay, this one is valid. Now for, let's say, size 4, this is valid, then this is valid. Now what is the maximum length I can do here? I can get 6. Okay, so one will be starting from here till here. So I have 3 ones and 3 zeros. This is one, and another will be from here till here. Yeah, so the maximum size I can get from this array is 6. So this is my answer. So now let's see how we can achieve this. So initially we will have a counter variable, and whenever we find a 1 in the array, we increment the counter by 1, and whenever I find a 0, we decrement the counter by 1. Okay, and whenever like we pass through the array, at every iteration we store the current value of the counter at in a hash map. So let me draw a hash map here. Okay, I'll just write it while moving. So initially I have a value of 0. Now for the first element there is a 1, so I increment the counter by 1, it becomes 1. I go here, it is 0, so I decrement it by 1, it becomes 0. It becomes 0. Now here it again becomes 1 by incrementing it. So as you can see here, I have a 1 and again I have a 1 here. So suppose if I have x at some point, if I had x and then I found some other elements, then I again get the value x in my counter. We can say that whatever happened in between, like whatever increment, decrement happened, ultimately it resulted in 0, because if it didn't result in 0, this value, this starting value and this ending value would never be the same, right? So whatever happened in between must have cancelled out each other. So that is why I have this and this value as equal. So I can say that if I find 1 here and I already had 1 before somewhere previously, that means all the elements after the left index till the right index, that is my current element, they are having equal number of zeros and ones, because only then I can have equal, right? Because for 1 I'm incrementing it I plus plus, and for like zeros I'm decrementing it. So if I have equal number of zeros and ones, only then I can have zeros, right? So considering that, I get 1 here, so I can say that this index, that is, we can store this index in a hash map. So whenever I found a 1, I'll store this in a hash map. Index was 0. Okay, now I found a 0, so 0 would be stored in the hash map at index 1. So now here, whenever I find a 1, we won't push this 1 in the hash map because we already have 1. We will take this value, and what we will do is write I minus this index 0 equals to my answer, right? So this is 2 and this is 0. So my answer is 2 here. That means size of the maximum array I have found till now is 2. So let me write down here 2. So let's move on. So after that it becomes 2 here. So I write 2 in the hash map and with value 0, 1, 2, 3. So it becomes 3. Now I go here, it again becomes 1. Now 1 is already there in the hash map. So this index is 4. So 4 minus 0 equals to 4. So what is the size of the subarray right now? This. 2 zeros and 2 ones, as you can see. So my maximum length is 4. Now let me erase this. Yeah, so after this I again go here and it becomes 0 right now. My counter becomes 0. So 0 is already there before. So what is the value I get? This is index 5. 5 minus, it was at index 1 from here, right? So 1 equals to 4. Now 4 is already my maximum length, so we don't update it because it's a pointless operation here. Now we go here and it's incremented by 1 again. Now 1 was like found at the very start. So I take this index, this is index 5. Was it 5? 0, 1, 2, 3, 4, 5, 6. Sorry, it was 6. 6 minus the starting index was 0. So it is 6. So this is my array now. This is my sub array. 3, 0 and 3, 1. So I can write 6 here. So my maximum length is 6 and we have finished traversing the array. So this is the final answer. Now moving back to LeetCode. So this is the implementation. So initially we have an empty hash map and current will store the current value. This is the counter variable and max will keep track of the maximum length we have found till now. So this is my loop and inside here we increment current if num size is 1 and else we decrement it. So now another condition is if current becomes 0 at some point, so that means from the very start till my current I, all the elements have, like considering all the elements, we have equal number of zeros and ones, because if you check here, initially my value will always be 0. Now at some point if I again get 0, that means everything that happened in between cancelled out each other, right? That is why I am again at 0. So if you check here, we have 1, 1, 1, 0, 0, 0. So 3 zeros and 3 ones. So for this I have written this condition, and after this condition is satisfied, then we check if it is in the hash map or not. So if it is not in the hash map, we simply put it in the hash map. So that is what happens for the starting values, that is for 1 and 0. For these two cases we put them in the hash map. Now for the third index here we get 1 and it is already in the hash map. So we like check with max, and so what we get the previous value of current, like where it occurred, we get the index and like subtract it from I. Okay, so that gives us the length of the subarray and we compare it with max and update it accordingly. Now after that we simply return the maximum value. So when we were at 2, we already had a 1. So what we did was did I minus hash dot get of current value. Current value was 1 and hash dot get returns us with this 0. So we do I minus 0. What was I? I was 2. 2 minus 0 equals to 2. That is 2 is my maximum. So initially maximum was 0. So then it gets updated by 2. Similarly it gets updated by 4 and then updated to 6. So that's the problem, guys. If you have liked my video, please like and subscribe, and if you have any doubts, please comment down below. I'll try to reply all of them, and that's it for today. See you in the next video.